Welcome back to Ask Jerry and Ray Anything About IBM Z. I'm Ray,
And I'm Jerry.
and today we're going to talk about what is the difference between mainframes and personal computers.
All right. So that's today's question. What are we going to talk about? Well, we're going to look at two things. We're going to look at technical architecture and capabilities, and we're also going to look at performance, scalability, and security, and show the differences between what's available on the mainframe and what's available on PCs. So Ray's going to discuss technical architecture and capabilities.
Yep, I'm more of a hardware guy, so I like getting my hands on things. Software, it's very hard to get your hands on the bits. Um, don't take that quote out of context. Um, so, in a mainframe, you're talking about a giant processor, right? It's about this big, and it has a lot more on it than your average computer uh, processor has. Um, I guess, for instance, the scale of it, um, the CPU part of a mainframe is about the size of a fridge, a little bit bigger than your desktop computer. Um, but what it does with that is it has lots of CPU drawers, which have multiple CPU cores, which have a whole bunch of different things on them to work in uh, conjunction with the specialty um, IO cards so that you can get a lot of parallel throughput and processing. Um, a personal computer, again, the chip's only about this big, uh, not quite the same scale. The clock speed of a personal computer is a lot slower. It has a lot fewer threads. Typical PC has maybe 8 threads or 4 cores for your hyper-threading capability. Uh, just really isn't the same. And the workload capacity for these is vastly different. The mainframe is looking more at your transactional capacity, and so it has to do a lot of very quick calculations, very quick processing, whereas your regular computer is generally going to be, again, regular compute processing. You write your Word documents, you make your uh, spreadsheets, you play your games. Um, those in the professional industry do video editing, but that actually offloads to the graphics processor, which is something that a mainframe doesn't have per se. Um, they're still using the terminals for the most part, but you can actually host a web server on a mainframe, so you can have web pages and GUI interfaces on the mainframe. But that's a topic for maybe next time.
All right. And I think the difference is design. It's a personal computer. So, you can't drag something the size of a refrigerator around with you wherever you go. But your laptop, you take it, you work at the
Mm-hmm.
beach, you can do things, in your office, you can do things on the back porch. You got a lot of flexibility. You don't have that, excuse me, you don't have that same flexibility with the mainframe. It's going to sit wherever it sits, and you can't do very much about that. All right. Now, Ray is the hardware guy. I I'm one of those people. I don't like to get my hands dirty. I like to work on the software. So we're gonna look at the difference between, and to me, this is the main difference. Basically, people don't really think in terms of the hardware. They think about what they can do, and that's what the operating system controls. So IBM Z is the operating system for the mainframe. There's series not there's IBM Series One, IBM I. That's what it is. There's IBM I, which is another operating system, but for our purposes, we're going to talk about IBM Z. And Linux on Z is also available, but like I said, I grew up with IBM Z, so that's what I'm really comfortable with, and it is designed to handle multiple users doing multiple things at multiple times. So over the course of time, it just grew and grew and grew. So at this point, it can handle thousands and thousands of transactions per second. The PC, on the other hand, was not designed for that. The PC, and we talk about Windows or Linux or Mac as operating systems, they're designed to, very quickly do the one thing that their one user wants to do. And they do that very well. But if they try and do what the mainframe does, bad things happen. They cannot handle that because they were not designed for that. I kind of think of it as a person, as a man who is truly devoted to this woman that he is dating. So he takes her out to dinner. They have good conversations. Everything is fine. That's the PC. The mainframe is a playboy. You know, have you seen the sitcoms where this man has double booked dates, and so he tries to spend a little time with this woman, and he says, "Okay, yo, excuse me, I got to make a phone call." He goes and tries to spend some time with the other woman, and he comes back. Well, the mainframe does that, except that it is so fast that all everybody thinks that they have their very own machine all to themselves. It gives you a second of time, and you go off and do something, and then it goes and handles somebody else, and by the time you're ready to do something else, it's back waiting on you. So that's one of the main differences with IBM Z. It handles, and by design, it handles multiple users doing multiple things, but all at the same time. All right.
Now, there are servers, Linux or Windows, that can handle multiple users logged in concurrently, but not to the same scale.
Right.
Um, you can get maybe a couple users logged on the box before maybe you start seeing a little bit of an impact. Mainframes can have hundreds, thousands connected at the same time.
Yes.
No problem.
All right. So moving right along. Ray's going to talk about storage.
Yeah, I also kind of spent a lot of time as a storage admin, so it's a interesting place. Uh, but yeah, mainframe storage. Again, it can be about the size of a refrigerator. Uh, you can have hundreds of hard drives, or now even flash drives. Or I'm sorry, not flash drives, solid state drives, uh, connected inside these boxes. Uh, RAID 6 is, I believe, the most common array, so that you have full redundancy. You can have multiple failures on a disk, or I'm sorry, multiple disks fail, and still be able to read the data. Um, these things are so complex. Typically, you have a local IBM, uh, either called a CE or SSR, customer engineer, or something support representative. I can't remember exactly what it stands for. But basically, they are your IBM people who come out to service your hardware or even install microcode updates. So that's like having somebody come to your PC whenever you have to do a firmware update, um, which most people can handle that on their own. You install a driver for your headset or your microphone, that's no problem. But on a mainframe, that kind of a thing, uh, it's a pretty involved task. Uh, IBM's gotten good about there being very little downtime, potentially no downtime for these kinds of updates, uh, but it's still not something you want to risk the average user trying to install themselves. Uh, but the way that the mainframe then uses this disk is, again, you have hundreds of people connecting to this frame talking to hundreds or thousands of different um, what used to be a circular spindle, um, and has grown up over the time and then shrunk in size. So now it's these tiny little cartridges. Um, but yeah, we call them volumes. Most people would call it a drive. But again, these are in a RAID configuration, so it's more than one drive. So it's, if you think about like a group of 6 drives working as one, uh, that's kind of your idea. But then can have replication between sites. It can even be in the same area, um, so that you have, again, better redundancy and failover possibilities in case of a disaster or a catastrophic hardware failure. They do happen, but it is very, very rare. You look at a PC, though, you typically have one, maybe two of these hard drives or solid state drives in your box, and you're typically only writing to one at a time. And going back to you're doing one thing at a time. Um, the PC doesn't have to have really specific I/O controllers to say, "Oh, this data has to go this way. We're taking this path," uh, so that we can, have load balancing across our cards. It is a very complex situation. So that is, you know, the basics of it. Sometimes you'll have someone, a tech type person who has a home NAS, right, network attached storage, where they can send data from their PC over to this little box in another room, maybe. But it's a very small amount of storage in comparison. Um, you can have petabytes, exabytes of data on a mainframe. That's a lot of data, right?
All right. So let's talk about scalability. No, let's talk about, Ray's going to talk about speed and throughput.
Yep. Speed and throughput, again, as I mentioned in the first part of it with the hardware, your PC kind of focuses on interactive speed of things. You say something to the computer says something back, and it's this back and forth communication that most, you know, computer users are going to be experiencing. You're not having the multi-thread. Well, the program itself may do multi-threading just to have things process a little faster, uh, but it's not like it's trying to do, 2 different things simultaneously. At least not very intensive things. Yes, you might be listening to music and working on a document at the same time, um, but those are very low in, CPU intensive activities. And so the mainframe, again, absolutely is the throughput master. Um, think of an ATM, right? How many people are looking at, pulling cash out of an ATM, looking at their balance on their mobile apps? All of that goes through pretty much the same, call it computer, the same server, which is a mainframe at a bank. Now, larger banks, yeah, they're going to have many mainframes, so they might be split out into regional processing, but at the same time, they're still handling hundreds, thousands, sometimes millions of these uh, transactions per minute. Is absolutely insane. And so, when you think about throughput and speed, uh, PCs do have benchmarks, and a lot of times we'll look at those benchmarks, but that is, again, just a very small number when you look at the millions of things happening on a mainframe at the same time. Comparison, but at the same time, you can't put one of these into your house.
You
Well,
can. You just have
I,
to have a
I
bigger house.
yeah, and there is actually somebody who's kind of became famous in the mainframe world a little bit ago. A couple of years ago, he bought a used mainframe, put it in his parents' garage, and he started tinkering around with it. I do not want to see that power bill.
Ray mentioned you say something to the computer and it says something back. Well, I was doing a presentation and I was trying to get people to see that I would do this and then the computer would do this in response. And of course, when I say something to the computer, that I talk in my normal voice. Well, when the computer responds, it talks in a different voice. And so a lady came up to me and said, "You realize you were talking in two different voices?" I told her, "Of course, because the computer has its own voice." So it's the way that we think about things. All right. So now we're going to talk about scalability. That's the that's the absolute heart of the mainframe. It can handle one user, it can handle 1,000 users, it can probably handle 1,000,000 users, like Ray was talking about, because it is designed to support that. You've got airlines using it, you've got banks using it, you've got government using it. All of these large entities are using the mainframe. And that's because they can give the person access to the machine. They can get to it with the ATM machine. They can get to it with their telephone. They can get to it with their PC. All of these are transactions that are going to the mainframe. So the mainframe is there. It is up. They say that some machines have been up for decades without rebooting. Without an IPL, which is the mainframe version of rebooting. My machine, if it stays up for 2 weeks, I'm just like ecstatic. It's like, wow, it's been up for 2 whole weeks. My PC. The mainframe, when it goes down, it's like a panic because it's not designed to go down. They talk about the nines, and it's supposed to be up like 9,99999% of the time, always up, and it only goes down when they take it down. It doesn't go down of its own volition. And PCs sometimes do that. They'll start acting funny, and things aren't going quite right. My first step is to reboot it and see if that issue goes away. You don't do that with the mainframe. The mainframe, if it's having a problem, it tries to tell you, look, I'm having a problem over here. Call somebody to fix it because I've got to stay up. And that to me is the whole scalability and multi-user support that we know and love on the mainframe. So Ray, you're going to tell us about security.
Yeah, security is also another thing. I dabble in it, which is uh, not. You really want to get in depth on some things. Um, Security is one of those things that you need to really take a good look at because it does impact you very much in your daily life. Um, again, on a PC, you're looking at malware, you're looking at uh, phishing emails, things of that nature, where you could potentially give somebody access to your personal information, and then they take that and they go and do bad things with it. Maybe they take out a credit card in your name. Uh, but again, these, not to say that, that's not, it wouldn't be terrible for you to experience that, but that's maybe a couple $1,000s, couple $100,000. Whereas if a company has their mainframe compromised, uh, you're talking millions of dollars in damage. Um, so, in order to protect against that, there are security products that are very strict about how they operate. You have to have, credentials, passwords, but then even past that, you have to be given explicit permission to do certain things on the mainframe. So to read, if Jerry has, we talked last time about data sets, right? Jerry has his own data sets. I have my own. If Jerry has not given me permission to read his data sets, I can't read them. So in order to share amongst your coworkers, your teams, you do have to open up certain things. But the security controls, again, can be tightened down in an instant just by revoking users or uh, removing the access to certain things. Certain programs have to have elevated authority to do what they do. But again, these are very tightly controlled in the operating system through the authorized program facility, APF list. You have to be on that list, or you can't do your elevated privileges. PCs, for the most part, you might get a warning once in a while of, oh, this computer is trying to do something that's going to alter, or I'm sorry, this program is trying to do something on your computer that's going to alter the way it functions. You get a pop up and you say yes or no. Mainframes have logs, very long logs, and you get messages in them that say somebody tried to do something they're not supposed to do. But you have to have somebody who's sitting there sifting through these logs looking for these things. Automation products that can send out emails or other notifications, create tickets based on seeing these messages come up. And so you really have to take security as a holistic approach, right? The mainframe can be the most secure platform, but if you are leaving your PC open and you're not locking it when you go to lunch, somebody could walk over and use your terminal to do stuff that they might not normally have access to, right? Jerry goes to lunch and leaves his PC unlocked. I could walk over there and start reading all his data sets. Well, maybe I'm upset at Jerry and I start deleting his data sets. Uh, Go back to the storage part where, well, there's lots of backups on the mainframe if you set them up. And that's the thing, everything is something-able, right? It is securable, it is, you know, available, but you have to set those up.
All right. So, bottom line, and I told Ray he could do this part because this is the grand finale. So,
It's the bottom line because Stone Cold said so. Uh, for those wrestling fans out there. But yeah, so when you're looking at the different categories of how PCs versus mainframes function, um, you know, typically a single interaction, the interactive interaction for a PC is going to be faster than a mainframe. Mainframe is meant to do tons of things at once. Um, but again, that increases its total throughput. So you can have hundreds of things happen, thousands of things happen in 1 second on a mainframe because of all these connected users. Your I/O performance is typically running at much faster speeds. The connections between the mainframe CPU and the disk storage is currently running, I believe, the latest iteration is at 25 gigabits, whereas the SATA connections inside your PC, it's about what, 6 gigabytes, maybe? So that's fast, but the disk storage itself has to be able to support that. And so the mainframe disk is meant to handle that speed, and so it can process much faster. And so, the final thing that we talk about a lot is the reliability of the mainframe. 7 nines is kind of the keyword that's thrown around a lot. So it is 99.99999% available. um, which is, I think it works out to just a few seconds of unplanned downtime per year. My PC definitely doesn't have a few seconds of unplanned downtime per year. It's more like a couple hours. But that's how they were designed. That's how we use them, and hopefully, you'll be getting interested in mainframes and starting to use them yourself. Aside
It's
from the
interesting.
ways you already use them, like with your ATMs and other things like that.
It was interesting that AI, based on a PC, had to confess that the mainframe was better. We talk about biases with AI, and I asked it one question. It just said, well, PCs are much better at this and they're much better at that. And well, yeah, the mainframe look, but this just kind of it said, okay, fine, I'll give up. Mainframe is much faster, extremely high, very high, and the PC is not. So, um, but they both have roles to play. You know, I grew up using a green screen, and I would use ISPF and work through that. Now I don't even know of anybody I don't even know how to go about getting a green screen. I use a emulator on my PC that looks like a terminal, and I can do work on that. And so they are different but very compatible and very useful together. So there's no battle between them. They are a cohesive unit, and I couldn't do my work without either one of them. So
The right machine for the right job.
exactly. All right, so that concludes our session for today. Uh, Remember to click that subscribe button, click the notify button so we can tell you what's happening, and we'll see you again next week.